Are you ready for your test next week? Or you got a lot more work to do?
I don't know. This unit is kind of hard.
Yeah, it's a lot of stuff.
But I think I'm getting the hang of it.
I was hoping this year it would be a little bit better, and then y'all had all that snow, so
Yeah.
I think it just made it harder than anything. But good morning. I didn't. Where's your homework?
That's what I'm saying. I literally could not find a textbook to get like the stuff on.
Yeah, you'll need to get it caught up by Tuesday.
I will. I'll get it done by tonight.
Also, there's probably only one more book assignment, I think.
Okay.
But somewhere in Google Classroom, I sent out the
really?
ebook version.
Oh,
I mean, it's been months now, but
I
it's in there
looked
somewhere.
Okay, because I tried to do like the one that's linked on the calculus website.
Yeah.
And it didn't work.
Yeah.
But
you
I'll
have to
get it
have-
done by tonight.
You have to have web assigned for that.
Okay. And Brooke said that her dance teacher's not letting her leave, so she might be late, just so you know.
Who's their dance teacher?
I don't know. Like their dance coach. They're like down there right now.
That's fine. They'll have to fix it, so.
Okay.
exactly.
Blake, Oliver.
Yeah. Oh, yeah. Who's the teacher for that?
Okay. Assuming there's a minute of silence today, you guys might want to turn in your number 80 bookwork while you wait, if you haven't done that yet.
Good morning, FHS. Today is Friday, January 26, 2024. Would you please join me in a minute of silence? Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
Blake, Oliver, Thompson, got a lot of Briggs. All right, guys, we need to, most of today is going to be set aside for finishing up, asking questions, starting to study for your 5154 quiz. That is next class, so if you've not put that on your planner to remember to study for that, you probably need to. But we need to talk about two things, two small things. One of them is on 82, and the other one I'll just have you write on the top of your test review. Then I had suggested you do half of the test review just to make today a little bit more manageable. So once we do those two things, I'll let you ask questions from the front or back of the front page of the review, since hopefully you've at least tried those. And then I'll give you the rest of the class to work on and finish up the review and figure out what it is you need to look at again. But the first of two small things I need to show you today is we talked about the second fundamental theorem of calculus yesterday. And once we saw the kind of pattern to that, those questions were very quick, I guess easy once you see and recognize the pattern. It was a good question to look back at because those are ones that don't take much work. You either know how to do them or you don't. So hopefully, I hope that you want those to be on the test. But we need to talk about the other direction as well. So again, the ones we talked about yesterday were questions like 1 and 2. If you take the derivative of an integral, if the bottom was a constant, the upper bound just gets to be plugged in to everywhere there's a variable. The one exception, like question 2, when you do that, if the derivative of the numerator, the derivative of the upper bound is not 1, you need to multiply by that. So in your notes, yesterday we did the full process where we integrated and then we turned around and did the derivative, but then we noticed that pattern. I need you to also be aware, this is not a fundamental theorem, but this can make some questions easier. In fact, question 4 in your test review does not have to be worked this way, but it could make the question easier. And I've seen AP questions, AP release questions, where they phrase these in a way where you could not work them any other way. So I'm switching the order of these. Instead of the derivative of an integral, it's the integral of a derivative. So now this is not the second fundamental theorem, but like we did yesterday, at least for the first couple questions, let's really break down and try to add a couple steps before we just go to what the pattern is trying to say here. Okay, so I'm going to leave the integration part alone for step 1. But this, what is the derivative of f of x? Okay, f prime of x. That's going to sound, it kind of sounds like a trick question. It's not a trick question. Derivative of f is f prime. Okay, now, also sounds like a trick question. This is integral, so I want antiderivative. What can I take the derivative of to get f prime? F. Now, I still need to evaluate it from 2 to 5. And so the answer to this question would be f of 5 minus f of 2. So once again, these two operations are inverse operations, so they mostly just cancel each other out. But if the derivative is on the inside, you still have to make sure that you deal with the upper and lower bounds. Okay, if we do this one as well, and we're going to squeeze in one step of work here just to help you see that. Do the integration later. What is the derivative of f of 2x? F prime of 2x? No, you can't just do the inside part. One more thing. Times 2 because of chain rule. The inside is a 2x. You got to multiply by 2. So here's the chain rule piece on this question. Okay, so this one didn't have chain rule. This one does have chain rule. Derivative of f prime of 2x would be f of f of 2x would be f prime of 2x times 2. Okay, and then if I just leave this 2 out for a minute, the thing that I can take the derivative of to get f prime of 2x would be f of 2x. And in this direction, we still need to evaluate it from 5 to 2. So you plug in 5, you plug in 2, you subtract those, and don't forget the chain rule thing times 2. So it could either be listed like this, or they might distribute the 2. I think the released AP questions I've seen, they distribute the 2. So from those couple examples, I just need you to first realize that there's a difference in the order of these. Derivative of an integral, if the bottom's a constant, that's second fundamental theorem. Plug it in or plug it in times chain rule, like we did yesterday. But if it's integrating a derivative, again, those are inverse operations. They mostly cancel out, but you still have to deal with the bounds. You still have to deal with the 2 to 5. And if the derivative of the inside is not 1 like this, then you need to multiply by that for chain rule. Okay, so go down here. I'm going to go through all of these again. So I've got one of each question for 5, 6, 7, and 8. So I'm going to verbalize all of that one more time, and then I'll ask you to try this row, and then you should know if you've got that, or at least which ones you need to look at again. Okay, so number 5, derivative of an integral where the bottom is a constant. That second fundamental theorem. That's the one we talked about yesterday. These two basically cancel each other out, but this gets plugged in everywhere there's a variable. So the y's become an x. Since the derivative of the upper bound is 1 and multiplying by 1 doesn't change anything, you don't have to write it there. But question 6, exact same thing, different constant, but again in our notes yesterday we talked about why the constant doesn't matter, just that it is a constant to do this trick. This gets to get plugged in, times, in this case the derivative of the upper bound is not 1, so you need to multiply by his derivative for chain rule. 5 and 6 are second fundamental theorem of calculus. Now once again, your AP exam, and for us as well, we try to be consistent with that. You need to know and be able to use the second fundamental theorem. You won't ever have to refer to it though. You won't say, I worked this with the second fundamental theorem. As long as you can do it, as long as you can recognize the pattern, then that's fine. Okay, 7 and 8 are the two that are different today, because now the integration's on the outside. So this is really like f prime. To integrate f prime, you go back to f. But the first time you should plug in 8, the second time you should plug in 4, and then you need to subtract those. Again, if you're familiar with this pattern, those can be the easiest questions. And of course, if it helps you, you can try to squeeze in this step like we did in question 3 and 4. I just verbalized instead of writing it down. Okay, in this case, the derivative of the inside was 1, so I really just multiplied this whole thing by 1. There's no real chain rule there. But the only other possibility, same type of question, but this one's going to have a chain rule piece. So the derivative of f of 3x would be f prime of 3x times 3, because of chain rule. So that's where the 3 is going to come from. The thing that you can integrate or take the derivative of to get f prime would be f plug in 9 the first time, plug in 1 the next time, and your answer could either look like this, or the 3 could be distributed. Okay, so of those 4 examples, any specific part of that you'd like me to say again before I have you try one of each on the right? Okay, this time, this is kind of unusual, but try not to look at the other questions. Try to work these 4 without your notes. 2 of them are second fundamental theorem. 1 has chain rule, 1 does not. 2 of them are the other direction. 1 has chain rule, 1 does not. But other than that, try not to look at your examples so you can see what really stuck and what you may actually need to look at again. that long enough? Okay, I'll give you another minute. Okay, so here's what you should have come up with as answers. Number 6. Now I'm just going to try to work these on the fly, partly to help you see that it shouldn't be any one of these questions shouldn't be taking too much thought, but if I have a mistake, then please speak up, because I'm working them in a fraction of the time that you did. 2 times. That's what I would get for those 4. Is that what y'all got? Okay. Is there 1 or 2 of those you'd like me to explain what I did, where those answers came from?
Could you explain number 7, the first one?
Okay, so since it was derivative of an integral, if the bottom is any constant, that fits the second fundamental theorem. So again, like we did yesterday, you can integrate this and then turn around and do the derivative. But at the end, all that really happens is this x squared gets plugged in everywhere there's a variable. So this t became an x squared, this t became an x squared, and x squared squared becomes x to the 4th. And for that question type, the chain rule comes from the derivative of the upper bound. Now, I'll be honest, I don't know if we have this question on next class's quiz or not. Some years we have had it, some years we have not. So I have not looked to see if I'm giving you any unfair information. But in the past we have asked one, I think like this, on this part of the unit, this unit test. And I would say it was it definitely was one of the most missed questions, and what people forgot was the chain rule part. So of all the stuff in this unit, this should be considered not on the hard side compared to some of the other stuff, so I would hate for you to miss that. Again, I'm not promising you it's on the test, I don't know, but even if it's not on this test, it could be on the next one. So okay, moving over, let's look at the review. There's one other thing I want you to write out on the top of your review, and then I will take the questions you have ready to go, and then you'll have some time to finish, ask questions, study, and get as close to being prepared as you can. So the thing that I'd like you to write down came up in a couple of our circuit questions. So if you were really paying attention to this, I think you should have already caught this, but this is an important enough property that I feel like it's worth talking about for just a second. So, all right, before I say what the property is, let me just try to visualize kind of why this works the way that it works. Okay, if I integrate 1 to 3, that's the same thing as finding the area from between the curve and the x-axis. Integration, one of its applications is finding area under a curve. So if I want to know the area from 1 to 3, I'm going to do 1 to 3, and it's going to look like this. And on a number line, when you go left to right, it's positive. So whatever this gives you should be your answer. But on the circuit, and again, this doesn't happen a lot, but sometimes the bigger numbers, the lower bound, and the smaller numbers, the upper bound. Now, me personally, I don't like that. That makes me feel uncomfortable. But if I'm starting at 3 and going towards 1, how does that compare to 1 to 3? Right, it's the same thing, but now it's going to the left, so it's going to be negative. It's the same idea as slope. When you count rise over run, when we say run, it's implied you're talking about counting left to right. If you want to count right to left, you have to make it negative. So the property says integrating A to B can be the same thing as integrating B to A. So anytime the lower bound's a bigger number and the upper bound's a smaller number, I personally just switch them. But to switch them, you need to multiply one of them by a negative because you're going the other direction. Doesn't matter which one you multiply by negative. So you specifically need to have that in mind for question 11. And 11 is kind of weird too because it looks like a multiple choice question, but there's actually 2 correct answers there. So again, feel free to change the order of the bounds of integration as long as you multiply it by a negative, because then you're going right to left, and just like on a number line, that means you're taking away whatever that area was. So let's make it subtract. Okay, so again, yesterday I had suggested that you work at least half of this just because it would help you identify some questions that you'd have ready to go, plus it makes you not feel as rushed to try to squeeze in the rest of your questions. And I had specifically asked you to try question 1 before you tried question 2, try question 2 before you tried question 3. So you really should have a good idea of which questions you would like a reminder on the front and back of the first page. So to start off, questions 1 through 6. Also, if you've not looked at the solutions yet, I remember when I did this years ago, I think I do like 1 question per page. So I tried to show a bunch of work for each question. So that is probably going to be pretty helpful too. If you don't have that pulled up yet, you might pull it up so you can check your answers and get some quick help on some questions. All right, Julia, what do you got?
I think it's kind of what we did today, but like the wording is something.
Sure. Yeah, so this is what we just talked about on the first handout. So I can do this one 2 ways. You can't always do this 2 ways. So let me say that. But this says f of x is the same thing as g of x. So if you want to replace this with, or g prime. Now you don't know what g prime is, but I guess you could find g prime because they told you what g is. It is 2x minus 3. But the pattern I was trying to get you to recognize is that who really cares? Because you're going to turn around and integrate it anyway. So it's going to go back to being this. And then you still need to evaluate from 1 to 3. So plug in 3, get 4, plug in 1, I think you get 2, subtract those, and you end up with 2 as a final answer. So technically, you did not have to know what we talked about on the last handout to do this one. The only reason, though, is because they told you what g was. So you could literally take his derivative, plug it in for f of x because they told you it was f of x, but then you just turn around and undo it. So that's what I'm trying to help you skip. If you recognize it's that question type, then really this integrating a derivative, there's just going to undo themselves, so it's going to leave you this evaluated from 1 to 3, which is the same thing that I ended up with there. Okay, Julia, is that enough for the way you tried? Okay. Again, you still need to look at that first handout we did, because again, sometimes they give you this where you kind of have a crutch and you can work it the long way and it's not that big a deal. But if they had taken out this, well, then I guess you couldn't do this question. They'd have to rephrase it in a different way, but they are pretty good at rephrasing it to see if you know that pattern. So, Okay, again, just sticking to 1 through 6 right now. What other ones have you tried that you would like a quick reminder on?
Can you do 6?
Sure. And I can probably tell you what the mistake was here. So when I look at, okay, so integrate 0 to 5, 3 plus 2, f of x. So most of the time you guys do a good job with this. This is going to be 2 times the integral of f of x dx. Okay, do you know what this comes out to be? So I know where you're having trouble. Okay, so then you need to start phrasing it as area under the curve. If you know the area from 0 to 3 is 6, and then you know the area from 3 to 5 is 4, then the area from 0 to 5 would be 10. Times that by 2, and you get 20. So it's like they're giving you the two pieces, and you have to see those being connected. The most common mistake here, though, is students do that, and then they say, oh, there's a plus 3, so the answer must be 23. And you can see they put that there as a distractor because that's a common thing. This doesn't say add 3 to your answer. It wants you to integrate 3, which is actually 3x 0 to 5. So you plug in 5, you get 15. You plug in 0, you get 0. So you really get 15 plus this 20, which would be where the 35 comes from. You have to integrate the 3 too, because the 3 is a part of the integral. You can't just add 3. If they wanted you to add 3, they put a plus 3 on outside of the dx. Okay, are you okay with how this 20 came about now?
Yes, thank you.
Again, anytime it's like asking you to combine these pieces, I know you don't have to say area under the curve in your head, but I think it just gives you a visual. If you know how much area there is here, how much area there is here, then you know how much area there is from here to here just by adding those together. So, okay, Julia, did you have a question on that?
On this one, like, I struggle with, like, finding the stuff you have in the red, because we haven't really done that since, like, the first day. So I struggle, like, figuring out how to get that.
Which part of that?
Like, the red. Like, I don't remember. Is, like, the 2, the 7, is that what it's called? Like,
Well, this is the 2 is just a constant. It's just doubling it. So just like with derivatives, you can do the 2 in here, but it's a lot easier to pull it out and just double your answer later. And for the f of x part, again, I'm just getting that by adding these together. 0 to 5, 0 to 3, 3 to 5, 4 plus 6 gave me 10 times the 2 that was there gives me the 20.
I guess I'm confused on where the 3 went to. Like, I know.
The 3 is right here. I still have to integrate 3 from 0 to 5. Integrate 3 from 0 to 5. The antiderivative of 3 is 3x. And then when you integrate that from 0 to 5, you plug in 5 the first time to get 15. You plug in 0 the second time to get 0. 15 minus 0 gives you 15. Is that enough? Okay. Somebody else? Front page only right now, 1 through 6. Okay, we can move on, but I do want to just make sure you should have asked if you had this question. But on question 3, you guys should not be spending much time trying to integrate this yet. Like, there's not some you only know 2 ways to integrate. I know integration's not easy, especially with how much practice you've had right now. But there's only 2 types of integration I expect you to do. Undo power rule and undo derivatives that we have memorized. We've not learned any other process. This doesn't fit either one of those. You can't just pretend like this is an x and just try to undo power rule from the beginning. You have to rewrite this. You actually have to FOIL this stuff out. You've got, just like the book assignment yesterday, you have to let yourself do a little bit of algebra to make it look a certain way before you should try to integrate. Don't try to do any crazy integration in your head. Okay, then the back of this would be 7 through 11. Again, 11 you need to have this property in mind, so you probably need to try that again before you ask that one. But the others, 7 through 10, any of those that you know you would like some help on. Of course, you should also pay attention to these 2 asterisks. The 2 asterisks means that you either need or you're welcome to use a calculator. Question 8, I don't think the calculator is going to help. Question 7, you can only do that with the calculator. So, huh? 7? Okay. So we've got this much water at the start. For the next 6 minutes, water flows out of the tank at this rate. How many gallons of water are in the tank at the end of 6 minutes? Okay, so this is like the circuit we did on Tuesday of this week, where you should put down the starting amount. I start off with this much water plus integrating the rate of water will tell you the change in water total. So the integration keeps up with the change. Now, the one thing different here is that, and you have to pay attention to this, water flows out of the tank at that rate. So we actually want to take away that. Huh? You did this? Yeah, so now it's ready for the calculator. But you have to, the same issue can happen to you on the AP exam. Everything we do in calculus is in radians. If you're trying to integrate any trig functions, your calculator is going to throw out a number that doesn't make sense for that. So make sure you're in radians, because that would be one of the things. But again, you cannot integrate, and also this would be 0 to 6, because I want to know how much water is being removed from hour 0 through hour 6. Again, you can't just plug in a 6 into the rate, because if you plug 6 into the rate, you're finding how much water is being removed at exactly the 6-hour mark, not how much water has been taken away over the 6 hours. Okay, I can help you with the calculator part individually if you don't get that. But. Okay, 8, 9. I know we put 1 like 8 on your semester exam last semester, and that was a new question for our semester exam, and you guys did really well on that, but we can talk about it again if we need to. Okay, but anything else from this page?
Number 10.
Number 10? Sure. Okay, this is G. Between -1 and 3, find where there is a local minimum. Alright, well, one thing is this is a calculator question, so we should not be trying to do any integration by hand. Even if it's easy, don't risk it. Just let your calculator do it if we need it. So, one thing I typically try to do is, I guess you could, now this is not a great strategy, I just want you to see why. You could try to graph this function that they give to you, and you could just try to find this local minimum. At what x value does that occur at? What's likely to happen, though, is this. It's working. This is really hard for the calculator to do, because as that x value changes, it has to recompute that. It's having to re-add up all of that stuff. So I guess you can maybe speed it up by saying, well, I really only care about -1 to 3. It's still not ideal. In fact, that's a little better than I thought. So instead of totally relying on my calculator, I would do a little bit of work by hand to help my calculator out. I know local maxes and mins occur at critical numbers always. Not all critical numbers are max and mins, but all local max and mins come from critical numbers. And critical numbers come when the derivative is 0. And the good news is we know how to take the derivative of that because we know the second fundamental theorem. The derivative of an integral where the lower limit is a constant, you get to just plug this guy in. So that would be sine of x squared times the derivative of the upper limit, but that would be 1. So graphing this guy and thinking about where he equals 0, is a whole lot faster. I can see there's a critical number at 0, almost 2, and about 2.5. But only one of these is a minimum. There's only one local minimum. So remember, this is a derivative graph. So when the derivative is positive, the graph's going up. When the derivative is 0, it's flat for a second. So the graph's going up, flat, flat, down, flat, and up. So which one of those would be a local minimum for the function?
2.5.
Okay, so where the graph was going down and then starts going up. Negative slope becomes positive slope. So that point right there, and since this is multiple choice, I can see there's only one even near that. It's about 2.507. So that's how I would do it. That kind of helps your calculator not try to do all of the entire thing on its own. I guess if there was a lot of choices close to that though, you would need to go to second trace, calculate a 0, left bound, right bound. We practiced this first semester, and then it can jump to that point. But again, I graphed the derivative. I was able to take the derivative because of the second fundamental theorem, and looking at the derivative graph, I can find the local min like we did at the end of last semester. So I think that makes that question easier.
Could you pull up what you graphed again?
Yeah, that's right here.
Oh,
It's the derivative of g.
yes.
So if you use the second fundamental theorem, that's how I got the derivative. Whereas that first graph may not have been finished yet anyway. So you saw how hard that was on the calculator to do that. Okay, it sounds like we've exhausted most of those questions from the front pages. So I'll start to come around and help you guys a little bit more individually. But again, you need to be aiming for finishing up the review, identifying which of these questions don't seem intuitive to you anymore, or just are not intuitive and that they haven't stuck yet, so that you can circle those and look at those again. Of course, I will ask for this to be turned in. I think this is already in Google Classroom, but you might want to turn it in as you finish it. And I don't know, I'll come around and try to help out on the parts that aren't clicking for you. I know I said this at the start of the semester, but again, to me, this is probably the most challenging unit we have all semester. I don't say that to scare you, I say that to help you guys know it's a little bit of a hill, it's a little bit of a hurdle. But your second assessment, so after we take this quiz on Tuesday, your second assessment is all the same stuff plus one question type, which is called U substitution. U substitution is probably the most important thing we do all semester. So I'm pointing out, I'm only verbalizing that to you because if you prepare really well for this test, your next test you only really have to learn one skill. So it could potentially be an easy unit for you. But right now, this is a lot of information. So, she had her hand up first. Yeah. Click with. Right. Okay, go to one. You see how that plot one is highlighted and those are not? You have plot one on. So move your cursor on it, hit enter, to turn it off, and then it should be. You were just trying to. Well, the difference would be, they're not necessarily different answers, I think they probably will be, but it's the difference between displacement and distance.
Because it starts with the origins.
Okay. So let's say this said 24 hours. After 24 hours, how much have you moved from your position? Probably none. You probably go to bed the same place you go to bed, right? But your total distance, you have to add up how far you travel to school and back and to your classes, and you got to add up all of those. So this one, I would do the starting location plus integrate velocity to know where it is. And for this one, I would integrate the absolute value of velocity so that when it's going left, it's still counting it toward your total distance and not taking away from the distance.
What is the calculated motion?
Part B would certainly have to be. Part A should be like. Yeah, we won't ask you, we won't make you integrate anything with absolute value signs because your AP exam doesn't make you do it. Well, I don't have to, you're gonna have to pull up the class recording and watch it to get them. Because you need the explanation behind them anyway, so. Okay, you guys got one or two I can help with? Yeah.
Yeah.
Can I help you?
I didn't see the way that I was.
Maybe. I'll let you pick that.
All I did was check.
Again, I said this a little bit earlier, but the solutions for this are ones that I worked out, and I used like one sheet of paper per question so I could show as much work as possible. I think that will help you catch some of your mistakes pretty quick and not different from somebody else. You guys got anything I can help with yet? Well, integrating gives you the total value, and then if you want average, you need to divide by something for in that question, because that's how many students it is. No. If it has two asterisks, you can do it selective. In fact, you don't know how to integrate that by hand anyway, so anytime you spent trying to do that on the test would be a waste of time. I only had 5 minutes to set period. Yeah, the other classes get 10 minutes.
Are you serious?
Yes.
That's so unfortunate.
This is happening.
Yes.
So we're doing Simmons to Wayne.
It didn't start till February, the bell schedule.
You didn't get advisory, or are they gonna take an
I think they might be taking 5 minutes away from advisory.
So each class gets how many minutes?
10 minutes.
Next year.
What would be 60-minute classes?
Every day.
That would be changing.
At the end of the day.
And they're all
Yeah, like 3:30, you could add next.
What's the 7th period?
because you're missing
So
the
7th
Not
period,
good.
just
and they don't
twice
want
as
us to
much
go
as
to
everybody
the
else.
actually already scheduled snow days.
And that wouldn't be fair, like,
Would it be fair
my
for
planning
teachers
is 7th
or-
period, so I get more planning time, that would be great.
Yeah.
But
We have an
Dexter
extra,
has 7th
like,
period class.
makeup days at the end of the year. I should argue them.
You guys not? No, so they're gonna shop.
I'm already going to
How long
time.
are you gonna have out every day?
I
Every day.
mean, I know the extra time sounds extreme,
It's
but
not
you
even-
also
that's
have to realize
extra
February
time.
is usually the worst month for snow. So there could be another 5 or 10 days.
That's more time.
We might
if
still
just
get
went
out of
that
June
way.
10th. and even doing the extra time, so.
That was the.
Wait, is it going to be like the beginning of the day or the end of the day?
Hopefully not.
Oh, students hate school and that's
Okay, so
I have something that I can do though. I don't have to be here for seventh period.
area under.
Well, they're not extending seventh period, they're extending first, second, and third, which is gonna throw seventh period off.
So,
Yes, but the thing is, will seventh period will start still before 3:30, and I don't have to. I don't go to the school for seventh period.
Add up
So
3 trapezoids.
why did they do this?
What's the total of what? 82.
They make the worst decisions here.
Since it's a trapezoid, it's gonna be 1/2 height times the bases.
Also,
1/2 times the height times the bases. 1/2 times the height times the bases. Okay. So what do you think the height of the first trapezoid is?
remember it's tilted on its side.
Why did you separate the colors?
Horizontal distance is actually the distance.
I didn't.
between the bases.
that is what color
The second trapezoid on his last one.
Now just go through all three and we'll get the actual cap.
What are the
Most
bases of
likely
the
not.
first trapezoid?
The true cap.
I finished it last night, right?
Yeah, I
Like, it was real close, and I know the lighting is awful. It's really hard to take photos on.
Wait, is that the typical
Second, no.
cap?
Okay, second trapezoid would be.
I just checked.
You cannot tell at all. That is.
Okay, so here's my three trapezoids.
How is it so hidden?
Now, if you look at these solutions, one thing that, I think, well, maybe I did. Of course, you could try to plot the point that's in the middle, sometimes it helps you. It might help you be a little bit more careful.
No, well done. That is.
But
And also, if you look really close,
that all cancels.
Sort of.
see that it has
Okay.
Just barely.
Yeah, there's 2 A's.
I did not notice there was an eyeball.
I know, I
Well,
particularly like details on the film better, but.
and now, here on the phone.
Yeah, it is.
Yeah, I mean, it's way too much to just look at it and say, oh yeah, K's got B's, that's very dramatic. The other thing you can do, I don't know, there's some data you're not good at, but
If I saw the other one, I never would have guessed that if it was there.
Worst case, if you can maybe just plug in 2 for K, or you're gonna
Well done.
try it and then see like if it does 2 and if it does have the right check, then it doesn't like that, so it's not the most efficient, but try and guess the check.
Or, I gotta add my numbers. Alright.
Oh, yeah. Like the dragon, I know.
I'm just skipping the ones out, like, I'm confused with that.
Well, all 3 of these you have to be right.
I just rewatched, like,
This one was like you
your
dragon
dragon.
distraction, then try to
It's still such a good movie.
Review before you make inspiration. This one you need to rewrite it, those trait functions. That one's,
What you're talking about these
Everything's gonna be 5 by 2.
That's a lot of artwork.
Yeah, it's all I can do, all I have to do for my art class.
And then so you, and then
Uh,
say, why am I doing this on the table?
Can we just do that one together?
And then that all equals.
You would need a calculator for part B. Since it's total listeners, you remember how we did?
Yeah, I know how to do it, I just thought we were supposed to use a calculator once it was with the asterisk, so I don't need to calculate unless Almanac could.
Well, I appreciate that, but we don't make you integrate absolute values.
Yeah.
Because you're AP doing this.
So K equals.
Matt, you got something I can look at with you?
I'm doing this one.
Okay.
I know you, you said function.
Yeah, you gotta foil it. Okay, so now that it's been foiled out, you can just undo the power rule 3 times. So raise the power by 1, divide by the new power, and then check it by doing the power rule. And then you just gotta do it 3 times, and since that one doesn't have bounds, you need a plus Z. But all the options have plus Z, so.
Hey.
What'd you get for 8 and 9? Or is that just, like, have you done these on the back?
This one?
There are 2 sheets.
Yeah. This one.
Oh, that? No, the other.
No, it's not one.
There's 2 pages of the words.
You only got 1 page of this?
But
there's extra copies in that basket.
Oh,
You just have to know what number it is.
A1.
Also, as always, I should have a few extra copies of the test review. If you really want an extra copy to work from scratch, you're welcome to print them until they're gone. Extra copies are always over here in the basket.
They're stapled. We do all of these on this page.
What, 12?
Yeah, it's just so certain that I repeated it twice.
Oh.
Sure.
Yeah, I should have plugged it in to get that. I guess you would probably.
Yep.
I mean, not.
We did a very, very limited color selection.
I'm more impressed
Are
that
you
you don't have
want me to
less
check your
pencil.
answer, or?
Honestly,
Yeah, I need to add that.
Like you did most of the drawings on, like all the drawings are only pencil.
Well, I only used the yellow one for this one. I used the blue for both.
I'm surprised that you still have pencil on.
I used red for the other one.
Wait, where is the red?
I didn't use it. I took a picture of it. It wasn't pulled out. Still on my bag.
I go through pencils way too fast. I keep an extra like box of pencils in my backpack because by the time I'm done with the class, the eraser just no longer exists. Is that an entire thing of just erasers? Yes, it is. That. Huh. Oh, have you seen there's pencils that are just erasers, but like,
Yeah.
Well,
yeah, those are cool.
You have one, or you have one in our.
Yeah, so if you're trying to find the area or integrate from something to something.
I was gonna say I need one.
Yeah.
Because I have no idea how much I wished I had found one. Very rough. I do especially most
You're finding the area
recently
under the
down
curve
to
to the
these
x-axis until you
out
see
of
the
color
x-axis will be
pencils.
one of the lines.
Oh, that sounds painful.
That's how I lost so much pencils in the face.
Well, you still need to integrate. You need to do the anti-curve first.
Can you erase colored pencil?
Yeah. I mean, not all the way, mostly.
If you've done the anti-curve.
And that's what the kids make mistakes that I
That
made.
shows that you're not.
Yeah.
Very easily at least.
Yeah, I can't tell.
That shows you've done the
I
anti-curve.
just never figured that out. I guess I
You
just
take an eraser and you just go paint.
every time I tried that, I just destroyed the pencil before I got into adults.
I have a restaurant
Nice.
and you.
I was trying to use like the eraser Trimble, like the thing with spin.
Yeah, pushing too hard, going too fast. A child. Raising a child.
Okay, I know this is really random, but does anybody have an iPhone? I think these chargers are called lightning cables, maybe? Does anybody need an extra lightning cable? I've got like, I don't do iPhones, and I've got like 5 of them.
But if it were really going to be 20 minutes or 20 minutes, 21 divided by 2 times 2.
So it's just taking an average and
That's how you do it.
It looks like that, but it's not.
Assuming that I know that, I might not, but if
Oh.
that's.
Apple did it so that you would have to buy a better charger.
it was meant to be a 5.
If you're curious why I have a bunch of chargers that I don't use, I don't think I ever told you this, but I used to be an Amazon reviewer, and people would just send me stuff and hope that I would review it. So,
Oh, that's nice.
yeah. Well, that's not a thing anymore. So. But I used to just get hundreds of phone cases and car chargers and
Yeah.
lots of pills, like herbal supplement. I didn't ever take them, but. Sorry, I don't want to keep interrupting y'all, but I don't think I have mentioned anything about CAP in here, have I? Okay, I know you're going through the CAP process. You've probably already put in a math course for next year if you're not a senior. Of course, that is still subject to change. You can still edit those things up until your CAP appointments. We don't generally talk about CAP too much in here because if you're in AB, unless you have decided you hate calculus, you know what your career is going to be, and you know it's not going to need calculus, then maybe you would not go on to BC, but the rest of you guys probably should go on to BC. But even if you think that's the case, please do yourself and myself one favor and make sure that you talk to some of your friends that are in BC. Just the nature of BC, there's just a lot less content that you have to go over. So BC is about half the speed of AB. So for that reason, even if you think AB is hard and you don't want more of that, because you get to go at about half speed in BC, you know, of course that makes it quite a bit easier. I know the naming convention may not be very intuitive to you, but it kind of shows you how those courses are set up. This is AB because you learn first semester is A. What we do in first semester is basically Cal 1 in college. B is like the first part of Cal 2 in college. If you take BC next year, you get to review BC, or review AB, so you redo the B unit, you redo the parts of Cal 2 that we do, which is this stuff, and then the only completely new thing is the C part. So there's like one semester of new stuff and one semester of review, basically. So, do any of you guys know of any of your friends that are taking BC this year? Okay, and they tell you that it's a lot easier?
Yep.
Yeah. So I'm only saying that because I don't want you to not take it because you think AB is hard. Unfortunately, AB has more content to it, but just the pace of BC is nice and slow. But the other thing I wanted to say, I almost lost track here. We also are offering a new math course next year, potentially. It depends on how many students sign up. That is the AP Pre-Calculus. So even if you have taken pre-calculus in the past, AP Pre-Calculus is a different course. So you could take it, it has an AP exam, you can maybe get AP credit from it if you pass the exam. Of course, AP Pre-Calculus is going to be much tougher than regular pre-calculus. But if you took regular pre-calculus, then you already know some of the stuff that's in AP pre-calculus. Some of the big differences with AP pre-calculus, though, would be you have to learn matrices and conics and some other stuff that we just don't prioritize or have time for in regular pre-calculus. But in an AP class where you guys can take on more and do more homework, you're willing to do the extra work, that's something that you might consider. So even if you've done pre-cal in the past, you might want to consider AP Pre-Cal for another AP course. But this was the first year that any school could offer it. We chose not to offer it this year, but we're going to try to offer it next year. If there's only 10 people who ask for the class, it won't make. It's too expensive to have a teacher teach a class with 10 students. So if 60 people ask for it, we'll probably be able to offer it. So. And I can't give you much information on that because we've not offered it before. But of course, it's AP. I think it's going to be pretty difficult. But again, if you've done pre-cal with us before, knowing some of that on day one could probably make it pretty manageable. Just an option. If you want to take something outside of BC and or AP Stat's a great course too. But if you think you need calculus or you might need calculus, you really should stay on the calculus track. So I wouldn't take Stat instead of BC. You can maybe take it in addition to, but if you're thinking of something outside of that, you probably should run your idea by me just so I can give you some feedback and at least warn you about why I would disagree with that before you choose it. Okay. But you want to know the area from the curve to the x-axis, right? Can't you find the x-intercept of that? Yeah. So we gave you one of them, but you have to find the other one. That's an easy one. It's going to be 0. Because my x is 0, y is 0.
I distributed.
So, you have to take, you have to like,
Yeah.
I mean, I guess that's right.
Not yet.
not yet, so.
You don't know how to take the antiderivative or something like that. You got to rewrite it and make it look different. That's what I was saying. There's only two ways for you to do the antiderivatives right now. Either it's one you just straight up memorize, derivatives memorize, or it's going to be undoing power rule. So if it doesn't work like that, you got to rewrite it.
Maybe.
What did you just say, like,
Okay, we could do that. I was thinking, split apart your fraction that way. What is your denominator?
You minus 2. Oh, no, I mean, it's whatever.
Okay, what was the first term?
You.
Second term? Okay. This, you could rewrite with exponent rules. Dividing things with the same base, you subtract the exponents. So that just becomes this.
Okay.
This, you could rewrite as, you could bring it up. And now that it looks like this, you can undo the power rule. You could raise the power by 1 and divide by this power. Raise the power by 1 and divide by this power.
Okay.
And then plus C or evaluate.
Okay.
What you get?
3 7 6, 3 7 6, minus 3 4 plus C.
And I think the next few questions on that are basically the same. I did not the same steps, but you have to think about how to rewrite it. So
Okay. Sounds good.
So 14, is that supposed to just say that it is only on that score, or is it supposed to be a second round?
There's the second one. You just have to find it on your own.
What do you,
Well, when we talk about integration, it's area under the curve to the x-axis, right? So can you find the x-intercept of this?
oh,
What's the function? X cubed plus 5x?
no, I can find the x-intercept, I just know that it had to be on the x-intercepts.
X, okay.
That's
What was it? X cubed
5x.
plus 5x.
I can find the x-intercept, it's
Yeah.
not hard, I just didn't realize it had to be on set x-intercepts.
Well, when you're trying to find the area under the curve, so we found, or we didn't find this one for you because we told you what it was, but the area under the curve is to the x-axis, which is the x-intercept. So x equals 0 was the hidden one that you had to think about. Okay, you guys still got 20 minutes to class, so there's still quite a bit of time to get some help if you need it. But I'm gonna stop bugging you every 5 minutes for questions. So please call me over if you'd like some help, or bring it up here to me.
then it's just triggered.
Yeah. Yeah, so just at Walmart, out of your pocket on it, and then do $20 on the key card. It should be fine. Of course, the other thing you might think about, I know you like your set of 30s, but do you have any classes with 30s?
So it's like, the
I was gonna say, even if you lost a couple, you might rather spend that money on something else for your class, and then
Did I say
just
that?
fill in a couple of, because you might have to come out and I don't know.
Yeah, I would've gotten it.
Yeah. But if you prefer to see the back up to 30, then that's just fine too.
Absolutely, idiosyncrasy. Thanks, man. Appreciate it.
So, on 2017, I raised the cap, I'm taking the in court, I changed it to the X interest. And then now I'm taking it back, so I raised the power by 1. And then we're just supposed to know that region means the whole curvy triangle.
Some of these are. And this is
So
where
it
I
gives
say
you
always check.
the bottom
So if you
which is
do
the
where
x-axis.
this, if you bring the power down,
It
that goes to 1.
Side.
Lower the power by 1 is 4. You can check by going through.
Gives you the other side.
But, the only thing I don't like is how you bridge it.
Basically, you're trying to do
You did the anti-bridge, but you're still doing integration, which means you haven't done it.
It doesn't list
Okay.
the left
Now
side.
instead of having that.
The left side is
You need
the
to
x
right
intercept.
So putting that there shows that you did that anti-bridge, but you did
Okay.
technically.
It doesn't list that. It
I
lists
know.
it here.
I know. But you're supposed to know that the region is everything above the x-axis in that range, which
Yeah,
is.
but the other is above the x-axis.
Just, it's where it meets. Yeah.
It's all above that.
Okay, well, it's the x, well, the x. Where the two sides meet, it's a region. So that forms a point at x equals 0, there's a point right there. I know, it bothers me, it bothered me as well.
It also doesn't list you have to the top or bottom. It could be from 4 until infinity.
It's the x intercept, that's what I'm supposed to know, but these are never told me.
And he lists it there.
Oh, wait.
Just move on for right now, but
Every
I'll
other
work it.
problem, literally.
Yeah.
That's, you have to, that's the.
It's not repeating that, it's weird, you don't have relation letter.
In some religions, like, how do you find
Without the highs.
So the graph acceleration letter.
Oh, you change it. You end up changing it.
Oh, okay.
So like, it's just taking. Yeah.
You watch Market every day. It's such a good animation.
Yeah, okay, I'm gonna just test it.
Why don't you watch TV?
So you do this
Or
in the
anything? Have you seen The Sun? Okay, so you do watch that.
I don't watch it, but I've seen it. I do understand that's not great brightness.
Also, an exhaustive resources listed by Fayetteville Public Library. I love I've been reading Wings of Fire and I'm the 9th book. They don't have any more.
minimum acceleration is sort of the director of this.
They got the 9th book. I haven't read it yet.
for speed of no. Why isn't it blurry?
No.
It was open for like over a second. It should have been a very blurry photo.
I cheated on the last one.
And you just held the camera very still.
That's not really possible.
Well, you have the acceleration function.
Yeah.
12t minus 36. That's just linear. I know the y-intercept's negative 36. It's just the slope's positive. Acceleration gets bigger the further right you go. So the least amount of acceleration is going to be 0. So I didn't really do any calculus to get that answer. I just knew that the least amount of acceleration would be before it went up at all. So.
Okay, a general solution is when you integrate and put plus C. A particular solution is when you integrate and then you plug this information in to find C. And then you can give your answer instead of plus C, plus C.
Yeah, I'm so. So on the answer key, it says the minimum velocity is at equal 3.
Yeah, and then I write what it was.
Oh, okay. I was just
Yeah,
wondering if you
I
could
just,
see that.
I should go back and do that.
Clicking. Because you're down to about 8 minutes, so you don't need to pack up yet. But similar to what I said a few minutes ago, again, I know this is a lot of information, but of course you guys want to put in as much time and as much effort as you can. Keep in mind that this, in my opinion, this is the hardest part of the semester. Second unit is going to be the same stuff plus one more skill. The third unit is the easiest one probably of the whole year. And the fourth unit this semester is the last of the new stuff. So this is a big hurdle, but it's also gets quite a bit easier after this. So please put in the best effort that you can.
I'm so sorry.
Okay. Well, this has an antiderivative. 3 becomes 3x.
Like, where they had a
3.
like, I don't know.
I'll just split it up. It's like derivatives. You can, if you've got more than one term, you can do the derivative more than once. Integration is the same. If you have more than one term, things being added or subtracted, you can split them up into the other.
And then you can't do it in this one.
You can't split it up anymore. No.
You can't like use it.
Well, you don't know what f is, so you can't do the antiderivative by hand. You're not told what f is. But again, if you phrase this as the area under the curve from 0 to 5, over here they're giving you the area from 0 to 3, and then they're giving you the area from 3 to 5. Yeah, so if you know how much area those two parts are, that becomes 10 times it by the 2 becomes 20. Plus,
I will do that.
Yeah, this is our
just 2 times bigger.
I think so.
One of my classmates is
That is actually